Hello students, in today's class we shall discuss about the scientific notations and significant figures. So let us see the definition of the scientific notations. The representation of any number in capital N into 10 power n form is called scientific notation. So you take any value, that value has to be represented only in this format, capital N into 10 power n. Let us see what must be the capital N value. Capital N value may vary from 1.0002 to 9.999 up to so on. Means it is very clear that while writing the scientific notation, after the first non-zero digit, we have to put the decimal point. It should not be after two non-zero digits, after 2 digits, 3 digits, we should not put. We have to put only after the first non-zero digit, you put the decimal point, and rest of the digit values or decimal positions we have to show in the form of the exponents, that is 10 power n form. Let us take some examples here. Let us take 1, 2, 5, 6. So this number has to be represented after first non-zero digit. 1 is the first non-zero digit. After first digit, you write down the remaining values now. 2, 5, 6 into 10 power. How many digits are there after the decimal point? 3 digits are there. So write down 3. Next, 6023 is there. 6023 can be written as first non-zero digit is 6, 6.023. So after the decimal position, again here 3 digits are there. So 10 power 3. 6, 6265 is there. So this can be written as again 6.6265 into after the decimal position 4 digits are there. So that we can write down it as a 10 power 4. Let us take other smaller values now. 0.000256 is there. So which is the non-zero digit first here? First non-zero digit is 2. So you write down the 2. Put the decimal point. Next write down the remaining values 5 and 6. 10 power. So before the decimal position here, because we put the decimal position here. Before the decimal position, how many digits we left? 1, 2, 3, 4. So if they are present before the decimal position, then we have to write down this one as a minus value, so minus 4. Next one, 0.00269 is there. Now first non-zero digit is 2, so that write down 2.69 into 10 power. Again before the 2, from the decimal point, how many digits we left? 3 digits we left, so write down minus 3. So writing of any number in this format, that is capital N into 10 power n form, is called the scientific notation. Now let us discuss about the significant figures. Significant figures means whenever you are taking the calculations or measurements in the laboratory, we know that we usually deal with the many number of the students in the classroom or in the laboratory. When you ask the number of students present in the laboratory to take the experimental values, then they come with the different type of the values. So in that values which is significant means actually which values are up to correct, afterwards which values are incorrect or estimated, means expected. So let us see the definition of the significant figures. Then we shall take some examples. So to make the definition, how to understand it. Significant figures means these are meaningful digits with known value. This known value is certain value. Certain means fixed value. Plus 1, which is estimated or uncertain. So here we are dealing with the two different values. One is the certain value, second one is the uncertain value. Certain value means fixed value. That value do not change. Uncertain value, whatever is we are dealing, that uncertain value, maybe it is the fixed one, it may not be fixed one. Means actually we cannot say that value existed or not. Let us take an example. So first of all, imagine 3 students are there in the laboratory and they are taking the different values for the same experiment. They are doing experiment and taking the measurements. So imagine A, B and C students are there. So the B student got the volume of a particular experiment as 11.2 milliliters, whereas student A got the 11.1 milliliter, whereas student C got the 11.3 milliliter. Now here, which is the fixed value? 11 is the fixed value. Which is not fixed value? The last digit is always not fixed. Which is the last digit here? 0.1, 0.2, 0.3. So here 1, 2, 3. These digits are not fixed. Means we don't know who actually got the exact value. Maybe this value is correct, maybe this value is correct, maybe this value is correct. That is what here it says that there are meaningful digits. Here some meaningful digits are there. In that meaningful digits, some values are certain values, some values are uncertain values. Usually the last value is always uncertain. So let us take here, this is certain value, 11 is certain value, fixed value, no change in all these 3 persons experiment values. Then which is not certain, this last value is not certain. Then here it is clearly written that plus 1 means for the last digit, if you add the plus 1, you will get the another person value. If you add again plus 1, you have to get the another person value. And if you subtract also, you have to get the remaining person values. That means the last digit value always uncertain up to plus or minus 1. Maybe it is plus 1 value or it may be minus 1 value. Now, let us try to see what are the rules to calculate or to know the significant figures. So, first one, all non-zero digits are significant. All non-zero digits are significant. Example, 6, 2, 5, 9 is there. So these are all non-zero digits. So how many significant figures are there here? 4 significant figures are present. Next, 1, 2, 4. So how many significant figures are there here again? All are non-zero digits only. So 3 significant figures are present. So all non-zero digits are significant. Next one. This is about these zeros. So how to deal with these zeros? Zeros if comes before the non-zero digit. Before the non-zero digit. They are not significant. So let us take an example here. Imagine 0.0256 is there. Here zeros are present before the non-zero digit, hence they are not significant. So these we should not consider. We have to consider only 2, 5, 6 as the significant figures. Then what is the use of these zeros? they only shows the decimal position. So here 3 significant figures are present. SF stands for the significant figures. Next, 0.001 is there. Here only one significant figure is there. Let us take 0.023 is there. Here two significant figures are present. So all zeros before the non-zero digit are not significant. Then what if zeros are coming between the non-zero digits? So zeros between non-zero digits are significant. Let us take an example here. 6023. Here 0 is present between the two non-zero digits, so this is to be considered. It has the importance, that is here now 4 significant figures are present. Now 160025 is there. Here two zeros are present between the non-zero digits. Total number of significant figures 1, 2, 3, 4, 5, 6 are there. So here 6 significant figures are present. Then what happens if zeros are coming after the non-zero digit? So after non-zero digit, so after non-zero digit means again here two rules are there. So let us take those two rules. After zeros are coming after non-zero digit and after or before the decimal position, means the decimal point has to be there. So with the decimal position, and second one is without decimal position. Let us take here with the decimal position. Example. See 0.02056 is there. Now question arises. See zeros coming after the non-zero digit. These two zeros coming before the non-zero digit. Hence these two zeros are not significant. This 0 is coming after the non-zero digit and with the decimal position is there. So this decimal position can be present either before the 0 values or after the 0 values. But if decimal position is there, then that has to be significant. Now here 1, 2, 3, 4 are there. So that 4 significant figures are present. Next, see 100.0 is there. See here, all zeros are coming after the non-zero digit. 1, that is. And decimal position is present either before or after. So 1, 2, 3 and this is 4. Totally 4 significant figures are present. Now let us see without decimal position. Example. 100 is there. See zeros coming after the non-zero digit without decimal position. Without decimal position means either this side or that side. Decimal position is not there. That's why they are not significant. So not significant. And these are all significant. So here we should not count the zeros now. We have to count the only non-zero digits. So only one significant figure is present. Now you take the 2000. Only one significant figure is present. 200 is there. Then 3 significant figures are there. Between the non-zero digits is considered. But after that, again not considered. So here 3 significant figures are present. This is about the position of the zeros. Next, third rule is about the all values or digits in the scientific notation are significant, but the value of exponent is non-significant. So let us take an example here. 1.6022 into 10 power minus 19 is there. We shall write down it's 1.6022 into 10 power minus 19. So in this, all these values are significant. That is, we have written earlier, n values are significant. All these values are not significant. What are the use of exponent forms? They only shows the decimal positions. That's why they are not significant. Now here, how many are there? 1, 2, 3, 4, 5 are there. So this is having the 5 significant figures. Let us take another example. 6.023 into 10 power 23. Here also only values present in the n form are significant. 1, 2, 3, 4 significant figures are present, and these are all non-significant. Next, let us go with another rule, that is counting of the objects. Counting of the objects has infinite number of significant figures. So let us try to see what is counting of the objects. Example, if we say 100, as we discussed here, 100 has only one significant figure. But if you say 100 balls are present, means after the number we are using an object, so it's a fixed value. This value cannot be changed. So this value is always having the infinite number of significant figures. Why infinite number of significant figures? Because exact values can be written with infinite number of the decimal positions. So 100 can be written as 100.0 or else 100.00, 100.000. So any number you can write down. These are all having the infinite number of the significant figures. So now let us discuss the precision and accuracy. Precision means it is the closeness of various measurements to the same quantity. It is the closeness of various measurements for the same quantity. And accuracy. It is an agreement of a particular value with a true value. That is called the accuracy. But if we study the definitions like this, it will confuse us. So let us take an example to understand this precision and accuracy in a better way. So let us imagine in a particular experiment, the answer of the experiment is taken as 2.00. So the teacher is saying that every student has to get the 2.00. Now imagine there are again 3 students in the laboratory, A, B and C. And the teacher asked them to take the 2 values and go for the average value. So imagine they have taken the 2 values and finally average value. So in this case, student A has got 1.93 first value and second value is 1.95. So obviously the average value could be 1.94. Whereas second student first value is 1.94 and second value is 2.05 and the average value is 1.995. For the C student, the value is 1.99 first value, whereas second value is 2.01, the average value is 2.00. Now, precision says that it is the closeness of various measurements for the same quantity. So, precision deals only with whether the values are close to each other or not. But it will not tell anything about that, whether these values are in agreement with the final value or not. Precision deals only with the closeness. If the values are close to each other, that is called the precision. These values may or may not be the agreement with the final value. So here you see these values 1.93 and 1.95. These are very close to each other, but these values are not equals to the final. The average value is not equals to the 2.00. So means these values, since they are close to each other, we can say that the student A has done the experiment with higher precision. So let us arrange this part also. So we can write down that here student A is with good precision but poor accuracy. Why poor accuracy? Because the average value is not equals to the final value. Whereas student B, see the student B values 1.94, 2.05. Very large difference is there. So these values are not close to each other. At the same time, the student average value, final average value is also not equals to the 2 value. Means here, since these are not close to each other, they are not precise. Since the final value is not equals to the 2.0, so it is not accurate. So not precise and not accurate. Now let us see the accuracy. Here the student got 1.99 and 2.01. These are very close to each other, so that precision is present. The final value is in agreement with the true value. So it is called the accuracy. Accuracy says that whether the values may be close to each other or not. Accuracy never deals with the closeness of various values. It only says that whether the final value is equals to average value or not. Once average value is equals to final value or true value, then that experiment is said to be highly accurate. The various measurements may be close to each other or not. If various measurements are close to each other, at the same time the final value is equals to the true value, then it is called as both precise and accurate. Now in this case, it is both precise and accurate. Now let us discuss about the rounding of the numbers. So in rounding of the numbers, sometimes we are asked to remove certain number of the digits, or else make it as either precise or accurate values. So in such cases, we may require to remove certain number of the digits. So in such cases, we cannot neglect the digit that we are going to delete, so that it has some value. That value has to be added or subtracted to the earlier value to make it its closeness value. So making the one value into its respective close value is called the rounding of the numbers. So in rounding of the numbers, basically three rules are there. If the last digit to be removed is more than 5, then add +1 to its preceding number. or digit. So example, let us take. So 1.37 is there. I want to remove the last digit. Last digit is 7, which is more than 5. Then what is to be done? We have to add 1 to its earlier number. Earlier number is here 3. So make it as a 1.4. That is rounding up. Next, if the last digit to be removed is less than 5, then no change in its preceding number or preceding digit. So let us take an example here. Again same, 1.34 is there. Now I want to remove the 4, which is less than 5. So that I can write down the final value is simply 1.3. There is no increase in the earlier digit value. Next, if the last digit to be removed is exactly 5, then two conditions arises. So if the preceding number is odd, then add +1. So let us take an example here. 1.35 is there. I want to remove the last digit. That is exactly 5. But its previous number is odd number. So then in such cases add +1. So it is 1.4. If the preceding number is an even number, then no change. Then no change in its preceding number. Example, 1.25 is there. Again, we want to remove the 5, but its preceding number is even number, so that no change in the value. So we can write down the value as 1.2. Now, in significant figures, while doing the multiplication, addition, subtraction, divisions, then how to report the answer, final answer? Let us try to see that particular content now. So here for multiplication and division. So for multiplication and division, let us imagine here 11.36 into 12.1 is there. So whenever multiplication or divisions are there, then you have to check the all the numbers given in that particular calculation. Then see that the number for which the least number of significant figures are there. Here 4 significant figures are there. Here 3 significant figures are present. So the answer also must have only 3 significant figures. Next, here also, let us take another example. 6.023 divided by 1.29 is there, or 296. Division. Here 4 significant figures are there. Here also 4 significant figures are there. So the answer must have the 4 significant figures. Same question, 1.6.023 by 1.2 is there. Then here 4 significant figures. Here 2 significant figures. So answer must have the only 2 significant figures. If you, whatever the value, extra value you are getting, make it rounding off using the rounding off numbers rules. Next, for addition and subtraction. So while doing this type of the mathematical operations for the significant figures, then let us take an example so that we can understand it in a better way. 12.236 minus 11.1 is there. So in this type of mathematical operations, here we should not see for the number of significant figures, but we have to see the number of decimal positions present after the decimal point, number of digits present after the decimal position. So the least values we have to report. For example, here 1, 2, 3. 3 digits are present in the decimal after the decimal position. Here only one decimal position is present. So answer also must be reported up to 1 digit or up to 1 decimal position. Even for the addition also. For example, 12.236 plus 11.39 is there. After the decimal position 3 digits are there. Here after the decimal position 2 digits are there. Answer has to be reported up to 2 digits in this case. So means multiplication division rules are different, addition and subtraction rules are different. For multiplication and division we follow the number of significant figures. For addition and subtraction we follow the number of digits present after the decimal position. I hope you all understood this video, and if you have any doubts, please do send your questions to the classroompoint@gmail.com, and we will clarify all these doubts in a particular separate video. Thank you all.